adding rational numbers. We are looking at page 14 and 15 in the hardcover. I'm going to go through and work some of my own here. But the big things we are going to talk about, I'm going to explain this here in this box, what we do when we're adding when the signs are the same. And when I'm saying signs, I'm talking positive and negative values. And ditto when the signs are different. So the book has many nice examples on your own. I certainly encourage you to take a moment to check it out here. It walks through things step by step. This problem shows you how to do this problem step by step, what's going on, this problem. Here's some more examples down here for you to look at. So please utilize it as a resource. So my rule, there's two rules here, and we're going to need this for both adding and subtracting. Multiplying and dividing, we have some different rules when we're working with positives and negatives mixed together. But two rules will apply when the signs are the same. So what we're talking about in this case here is if we have a positive plus a positive or a negative plus negative. That's what we're talking about when we say the signs are the same. So looking just through some of these here, certainly some of these will meet that criteria. Number 2 meets that criteria, negative and a negative. Number 7 meets the criteria, a positive and a positive. Number 9, yep. So those are examples of signs are the same. So when the signs are the same, what we do is add the values together. Carry the sign over to your final answer. And we will practice with just focusing on some adding with same signs for the moment. So just to illustrate this, just for our explanation here, I'm going to use some very simple numbers here to drive this home. 7 plus 4, all right? Positive 7 plus positive 4. And this is by far the easiest of all of them, of course, to understand, because we know that when we have two positive values and it's adding, we just add the values together. 7 plus 4 is 11. Positive or negative? Well, it's positive. Of course it's positive, because this is a positive here, this is a positive here, and when we're adding and the signs are the same, we just carry the symbol over to our final answer. Add the values together, carry the sign over. This is the same for negative values. If I write negative 3 plus negative 6, the rule is the same. First, add the values together. 6 plus 3. What's 6 plus 3? 9. But this time, it's going to be a negative 9. And why? Because we're adding two things with the same sign. So we carry the sign over. So when the signs are the same, positive or negative, add the values together and carry the sign over. Positive plus a positive will always equal a positive, and a negative plus a negative will always equal a negative answer. Always, 100% of the time. Okay, so let's look at a couple here. I'm going to just move on a little bit further in here. Again, the ones that are like signs, you can add this, no problem. Number 2, again, 6 plus 4 is 10, negative 10. I'm more interested in a couple that are a little more challenging. And again, we don't have calculator access yet. Chapter 2. So this is certainly a little more challenging due to that element. But unfortunately, if you had a calculator, there's nothing to learn by just punching this into the calculator and the equal button. What have you learned except pushing the buttons on your calculator? So there's no skill or effort in that. you are being assessed on your ability to do this stuff. Chapter 2 on, we're assessing different skills. But right now, the objective is that you can add the rational numbers, not your calculator. By all means, though, feel free to check your answers with your calculator. I'm not saying you can't. Please do. But on the quiz and test, you will not have that available to you. But by all means, use your calculator on your homework, preferably attempt the answer first and use your calculator then to verify your work. Okay. So let's look at number 11. We can do that one. Negative 9 9/10 plus negative 9 9/10. So signs are the same. Agreed. So what do we need to do? Add. So I would just set up a little addition bar, maybe rewrite it in vertical form. Vertical form is like this. This is horizontal form. Rewriting them in vertical form will be very helpful. Add just like normal. Carry the one. Looks like I got 19.8. Positive or negative? Negative, because we always carry the sign over. Let's look at number 19. Five 14ths plus 8 21st. So adding, signs are the same. So final answer, positive or negative? Yeah, it'll be positive because we're adding a positive and a positive. So yes, positive something. So now I got a couple fractions. What's my move here? What do I need to do first? Leah. Exactly right. We need to get equivalent fractions that have the same denominator. So both of these fractions need to be rewritten. What is my least common denominator between 14 and 21?
7.
Least common multiple. That's the greatest common factor.
21.
14 doesn't go into 21.
Wait, what?
42. Right. So I have 5 14ths and I have 8 21st. So I need to rewrite both of these fractions with that denominator of 42. So you guys fill in the top. And 14 times 3 is 42, therefore on the top we have a 15. And down here, 21 times 2, and down here we got a 16. So I got 15 40-seconds, 16 40-seconds. Oh, yeah.
Do you want us to estimate by rounding for the
No,
corner?
no estimating. No.
You
Just
want us to
just
solve?
add. Do the then add part.
Okay.
No estimating. Yeah, it says, her question was right here, it says estimate by rounding. No, that's what I want you to do. I want you to add it. Okay, ignore the estimating part. Ditto with over here. Ignore estimating at any point in any lesson the rest of the year, all right? All right, you guys have a good weekend. Again, I'll get this up there for you. Sorry you have to leave. Okay. So from this point on, how do we finish this off here? I did write two equivalent fractions. How do I finish it? I add what?
15 over 42 and 16 over 42.
Well, yep, we add these two, but when we're adding here, we add the numerators. So 15 plus 16 is 31. What's the denominator? 42. Right. The denominator never ever changes. We don't add the denominators together. All we do is add the numerators. But we can't do that until we have established equivalent fractions. You can't add fractions until they have the same denominator, which means our first step is we need to find what that common denominator is, write the equivalent fractions, and once you're there, then you can go ahead and start doing your math to solve it. Okay? Why don't you guys try? let's look at number, looking for ones with more like signs. There's not too many of them left here. No, I'll just make one up then. How's that? Negative 1 1/5 plus negative 0.8. I'll give you a moment, but we have, again, same deal. It looks like they are both negative, so we are adding them together, right? But what's the first move we probably want to make here?
Turn the mixed number into a decimal.
That's perfectly fine, or you could turn this into a fraction. Either one's acceptable. I'll work it both ways just for the video here. One time, both are acceptable. But if I go Nolan's route, we'll do your route first. So negative 1 1/5 as a decimal is?
Negative 1.2.
Negative 1.2. And if you're not sure, you'd have to set up your division bar. Minus 10, and there's my 0.2. That's where it came from. So I just divided the fraction, 5 into 1, 2/10. So plus negative 0.8, add them together, what do we come up with?
Negative 2.
Right, 1.2, so I just set this up, I get 2.0, 2 or 2.0 if you want, doesn't matter. Positive or negative?
Negative.
Right, definitely negative, because all we do is add the values together and then carry the sign over. All right. If you did it the other way, negative 1 1/5, and then you'd have plus, negative 4/5. So 1/5 and 4/5 is 5/5, which is a whole fraction, that's 1, and then I still got 1 here, so I'd end up with 1 plus 1 is 2, negative of course. Either way is fine, there's no right or wrong, whatever you're more comfortable with. Some of them are more logical about what you want to do. It's good if you're comfortable doing it both ways. Different problems will present themselves different opportunities that lend themselves to one method or the other. So it's very good if you can be comfortable doing it both ways, just because, again, some of the problems will be significantly faster and easier. Either this one, again, getting it to decimal, I mean, that was great. It was wonderful. You could probably go either way with this one, but some of them will be a little more tricky. Okay, let's focus on, and a lot of these problems do focus on the unlike signs, and this is where it gets slightly more difficult. And the sooner you can learn these rules and apply them properly, the easier your life is going to be here. But we are talking about when the signs are different. In this case, we're talking about a positive plus a negative, or a negative plus a positive. And unlike our first rule, where I knew definitively what our final answer would be, that is not so much the case here. So I can't definitively tell you if either of these are going to be positive or negative, and we'll find out why in just a moment. But what do? And I explain it my way. The book has a somewhat different explanation. I'm going to pop it under the camera when I'm done, and you can see which one you like more. But when the signs are different, what we do is find the absolute value of both numbers. Okay? Find the absolute value of both numbers. Once that's done, subtract, not add, subtract the, and I'm just going to put AV, that means absolute values. Subtract the absolute values. So it will look like this. Whatever has the greater absolute value is on top. Whatever has the smaller absolute value goes on the bottom. And whatever you got, answer. Okay. So at this point here, we're not really having any consideration to my final answer being positive or negative. But we'll take the greater absolute value, we'll subtract the smaller absolute value, we'll end up with a positive number at this point here. Then, to determine if it's a positive or negative in your final answer, carry the sign of the value that had the greater absolute value. And this will determine if your final answer is positive or negative. So I'm going to work through a couple here. Again, I'm going to just use some very basic numbers to help illustrate the point a little bit. So I'm going to say 6 plus negative 4. All right, 6 plus negative 4. And indeed, the signs are different. This one's positive, that one's negative. So what I need to do is I need to find the absolute value of both. And usually I don't write this part out here. It just, when we're dealing with absolute values, what is absolute values are what? What's the definition of an absolute value?
Distance from zero.
Right, tells me the distance from 0. And it doesn't matter if it's greater than 0 or less than 0. It's purely a whole number, counting number, positive number. Absolute values are always positive. Always, 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 always. So the absolute value of positive 6 is 6. Positive 6, of course. The absolute value of negative 4 is 4. Positive 4. Absolute values are always positive. So what we're doing here is we're generating two positive numbers. Okay? So now I've done that. Step 1, find the absolute value of both numbers. Boom, there it is. Next, subtract. So the greater absolute value is this one. 6 is greater than 4, right? There's my smaller. So I subtract. I'll end up with a positive number, of course, which is 2 in this case here, positive 2. And now we're almost done. Now we have the last step here. Carry the sign of the value that had the greater absolute value. It's always going to be the number that you did on top. Always, because the greater goes on top. So my question to us is, this 6 here, was this the positive value or the negative value?
Positive.
It was the positive value. This was the negative value. That means my final answer will be
Positive.
positive. Right, because the greater absolute value was 6. The 6 was positive. That's the symbol I carry over to my final answer. So I'm going to do one more. This time I'm going to do negative 6 plus 4. And we're going to apply the exact same rule, the exact same process that we just did. So again, I'm going to be extra clear just for this one here, this one time. So the absolute, oh, this was a positive 4, my bad. Positive 4. So the absolute value of negative 6 is?
6.
Absolute value of positive 4 is?
4.
So I'm left with 6 minus 4 is 2. So really not a lot has changed between the first problem and the second problem at this point. But what's going to change?
The size.
Right. Why?
Because it was originally negative.
Exactly. The absolute value of negative 6 is 6, which is greater than the absolute value of positive 4. So 6 is still greater than 4, but this time the change is the 6 is the negative this time, which means my final answer to this one is a negative 2. So the subtraction never changed. It's still 6 minus 4, no matter what. The only thing that changes is right at the end, determining your final symbol. So you can go the other way. If you want to start out and look at this and go, this has the bigger absolute value, I know my final answer is going to be negative something or another, right? It's got to be. You can just look at this and go, this is going to be greater than this. So then you can do your math, but if you want to set your symbol in the first place there and just get it in position and then either just do the addition or subtraction, hey, all the power to you. There's nothing wrong with that at all. So, okay, so let's look at a couple of these. How about number 17? And again, I'm kind of moving down on the homework here. I'm thinking you guys will be okay on the 1 through 15, so figure that out on your own. I'd rather do a little fraction practice with you at the same time. 17. Negative 8/9 plus 5/6. What do we want to do first?
Find the least common multiple.
Right, we need a common denominator. What's my common denominator? 18. So rewrite both fractions. Over 18. That's our first step. So 9 times 2 is 18, therefore 8 times 2 is 16. Just multiplied that by 2 to get there, so I got to do the same up here. 6 times 3 is 18, and on the top, 5 times 3 is 15. Cool. So this is where we're at here. Now we can go ahead and finish this off. So, need the absolute values. Which one has the greater absolute value?
Negative 16.
Right. So what's that tell us about our final answer? It is going to be a negative something or another. It's going to be negative. So I know now, I've already figured that out here, but I'm subtracting. I'm going to subtract the absolute value from this. So what's 16 minus 15? In the denominator is 18. And there's my final answer. So one more time, just for the video purposes. Again, writing all this out, I hardly expect you to do it for every one. But if it helps you, hey, all the power. Nothing wrong with that. There's the greater absolute value, subtract the lesser. So there's where I got my 1/18 from. And then again, this one had the greater absolute value, so I need to bring that symbol down here. Okay? So when the signs are the same, add the values. When the signs are different, you're going to be using subtraction. Right? Even though they're all presented as addition. We're going to do a couple more. I want to get to some of the chunkier ones here before we head out the door. 31. What's the answer?
Oh, 15 over 6, yeah.
Did you have to even lift your pencil? 9 and 15 sixteenths. You see why? What about, remember additive inverses? And they litter these in here, right? You see that there. Negative 9 and 4/15 and positive 9 and 4/15, add them together, what do you get? So they're gone, so what is the only thing I'm left with? Right. So some of these others have some built-in things here. Let's try number 29. Let me see what's on the back here. Number 29. So there are truly many, many avenues to success for this problem here. So many that trying to write them all out would be spend the whole class breaking them all down here. So when we are adding, again, they throw in some brackets here, but truthfully, the brackets are fully irrelevant. And we'll have our properties lesson soon enough, but when we're adding, we can add things in any order. So you can certainly work just left to right, figure out what 17/9 plus negative 5/36 is, and then take that answer and add it to 4 1/4. That's fine. But my personal preference is to look for things that I can combine. And we said this term last year, combine like terms. So I think it's easier to add all the things that have the same symbol together. And then my final step is I'll have all the sum of all my positives, I'll have the sum of all my negatives, and then finish it off by adding those two values together. So when I see this here, what I would want to do, at least in my opinion, is add these two values together. I want to add a positive and a positive together. That's what I want to do first. So you can convert this to an improper fraction. You can convert this to a mixed number. We're going to need a common denominator. All these things are going to happen. But I'm just going to, how do you want me to do it? Should I make improper fractions, mixed numbers? What do you want me to do for you? Great, so we'll turn this into a mixed number. So this is going to be 1 8/9 plus 4 1/4. I am not dealing with this right now because this has a different sign. I want to combine the two that have the same sign. So now I got them both in mixed number form. Common denominator is what? 36. So I'd have 32/36 over here, and I'd have 9/36 over here. Agreed? Now, I'm just going to add as is, so the fractions 32/36 plus 9/36 is 41/36. And then 1 plus 4 is 5. And I'm going to generate a new mixed number. This is a mixed number with an improper fraction. It ain't real cool. But I can take 1 off here, 36/36, add it into here. So now I'm at 6 5/36. It's the same thing. All I did was subtract a 36/36 here, which is the same as 1. And then I put it back in right there. So I've simplified this down here. Okay. Then finally, now that I've combined, I have a positive, I have a negative. So take the absolute values. I think we all know this has the greater absolute value. Agreed? Right. Subtract the smaller, subtract 5/36. 5/36 minus 5/36 is no 36 or 0. So what am I left with? 6. And then is it a positive 6 or negative 6? Positive, because this one had the greater absolute value. You guys want to do one more, or you just want to be done with this? Done? Okay, fair enough.